We are live. We are live. We're live. Look at this rather shiny jacket that I have on for this live with you right here, right now. Welcome one and welcome all. Indeed, welcome, 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 welcome to this live. We're live. I am back to Boston. There's no more traveling. I mean, not for a little bit anyways. I'm back home. The kitty cats have been most wonderfully welcoming in spite of the little bit of a few days away from them, and they have had a good time with their grandmother, and I'm still hanging out with my mom and the kitty cats. And thank you so much, universe. And hello, Nathan, hello. Nathan says, hello, B. Thank you so much for being here already. Welcome, 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 welcome. How is everything going with you, Nathan? How is it going? Please do like the live. Please do like, share, subscribe, comment, share a chat message, share a comment in the live. I will read it out and I will give you a shout out. So thank you so much indeed for being here. We will cover some new and exciting topics today. We will cover cosmology today. We will cover the universe today. We have books with us. We have chats with us. We have some friends with us. Looking forward to seeing many of you old folks as well as new friends here today, right here, right now. Oh my gosh, that's right. Are you in the Midwest? There is some bad weather there. Nathan, El Chalon, Nathan again, Faze, hello. Thank you so much. Thank you for liking the live and sorry about the bad weather. Stay safe. El Chalon says ciao, ciao, ciao. Hello, El Chalon. Lovely to see you. I'm glad to have you back, says Nathan. Thank you. Faze says, hey, tornado warning the last few hours. Oh my gosh. Well, welcome Northern Indiana, welcome Midwest, welcome USA, and please do take care. Hopefully everything is good and goes well. Thank you so much for being here. Welcome USA, welcome all the countries, welcome UK, welcome India, welcome Europe, welcome Africa, welcome Asia, welcome North America, South America, Australia, New Zealand, Antarctica. Welcome, 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 welcome. Hello, Charles. Hello, Nathan. Hello, El Chalon. So we'll spend a few minutes saying hi to everybody and seeing your chat messages and reading them out and seeing your usernames and giving a shout out. And then we will read and reference the books, A Brief History of Time by Stephen Hawking, as well as we have a new book here today that I can't wait to show you. Here is the new book that I got from the library to also use on this live stream. This is going to be The Elegant Universe by Brian Greene. We will talk more about it. We will, do you do a weather section? I don't usually, but I can. It has been sort of cloudy, sunny here in Boston today. Tomorrow there will be rain all day. On Friday, I think we have a cloudy day, but no rain. Saturday has rain. Sunday has light rain. And Monday hopefully has no rain because I do want to go get Ethiopian food on Monday after the library. So that's the weather section of this live right here, right now. Thank you so much for asking. Charles, hello. Kitchen sink, hello. Nathan, hello. Kitchen sink again. What is happening here, you ask? Well, I think I just told you. Thank you so much for being here. Welcome to the live, and please do like the live. Can we get 17 likes? Can we get 10 likes? Can we get 20 likes? Mysterious Matt says, hey. Hi, Mysterious. Bickle Gaming says, in which city living? This is Boston. I thought you were going to read if you give a mouse cookie low. Nyla says, you're so beautiful. Thank you, Nyla. Thank you so much for the weather section. Of course, there is some rain here on the East Coast, but I hear that there are tornadoes in the Midwest. So we are thankful for no tornadoes. Thank you so much, universe. Thank you, God. Thank you for kitty cats, and thank you for physics, and thank you for being here. Hi, Nyla girl. Hello. Let's see. Did I miss anybody? Again, hello, Nathan, El Chalon, Faze, Charles, Kitchen Sink, Mysterious Mats, Bicycle Gaming, Nyla. Very nice. I'm a comparative religion researcher on Quran and Bible in the light of modern science. That's very interesting, Mysterious Mats. Are you at Boston University? Indeed, I am not currently at Boston University, but that's a good question. Nathan says no Doro yet. Michael Gaming says I love you. Thank you. Love you too. Do you live alone? Why do you ask, Nyla girl? You seem very intelligent. I would have guessed Harvard, but it's not in Boston. It is in the Boston area. It's in Cambridge, which is in the Boston area. Actually, Cambridge is just across the river from Boston. So Boston area is not that big. The Charles River, here's the geography section of the live. The Charles River goes through the Boston area, through Massachusetts, and on one side is Boston and the other side is Cambridge. And Cambridge, most of it is Harvard, and a little bit of Cambridge is MIT. So that's the geography over here, and I live sort of north of Boston, very close to Boston, very close to Cambridge, all of that. How was the trip? It was good. Lots of sunshine in North Carolina. The South has definitely, I mean, the Carolinas have really nice sun. Even on a cloudy day, there's plenty of sun to go around. So it was good. Kitchen Sink says, oh, I see. Because it sounds quite in there. That's why. Quite in there? In there meaning? Michael Gaming sends blue hearts. Thank you so much, Michael. Really appreciate it. Everybody, thank you so much. Could you please like the live? That would be very much appreciated. If you could like the live, could we get 10 likes? And then I usually ask for 20 likes. That would be really nice. She has multiple roommates, cute furry ones. Yes, indeed, my children are cats, and they often appear on these videos. So thank you so much for asking. I do have kids who are cats, and I talk about physics, and the channel is mostly kitty cats, physics, astronomy, astrophysics, and cosmology. Thank you so much for being here, though. I love to say hello to everybody, welcome everybody, get settled, say hi, hang out a little bit, and then we usually get started with the topic of the day, which is going to be the universe, of course. Only, but absolutely, the universe. North Carolina is where I'm at. The view is so pretty. Hello, 908VR123. Lovely to see you again. Lovely to see you again, 908. I believe I've seen you in the past. North Carolina, it's very pretty indeed. What is your name? Thank you. Like the live. Yes, please. I'm going to get you 100 likes. Wow. Kitchen Sink, please do. Sounds amazing. Hi, 908. John Foster, hello. If you're interested, I can share a few linguistic and scientific facts from the Quran that may blow your mind. Go ahead and share anything you'd like, my darling. Mysterious Maths is about to share something from the Quran. Go right ahead. Sounds like a nice trip. Yes, thank you. How are you, John Foster? I feel like haven't seen you in a bit. Have you been missing my lives, John Foster? And what is up with that? Very nice. Thank you so much for liking the live. Thank you. Michael Gaming, thank you for the emojis. Been out of town working. Oh, well, good luck and all the best and congratulations. Kitchen Sink says, here we go. Yes, we're going to get started, actually. I think I've got most of you. If I missed you, please do say hi again in the chat. Feel free to say hi multiple times and catch up with each other and say any comment that you would like to say. Make a live stream, 1,000 million like. Oh, thank you. Thank you so much. That's all very encouraging. Everybody, thank you so much for being here and being so encouraging. Lovely to see everybody, and we'll get started. El Challen says, got my first 1,000 views on a YouTube short. Wow, very nice. Congratulations, El Challen. Love it. Okay, I'm gonna get some sips of water and then I'll tell you about this new book that I got from the library. New as in to the channel. So we talk about a lot of different books on the channel, and especially centering on the topics of physics, astrophysics, cosmology, astronomy, and things like that. So lately, reading and sort of talking about the universe and the various things about it has been very interesting, both for me and I think for our discussions. So that's what we're going to do today. And we will talk about this book called The Elegant Universe by Brian Greene. I was going to say Ginn. I don't know what that means. Brian Greene. Superstrings, hidden dimensions, and the quest for the ultimate theory. So as you know, we have actually mentioned and talked about superstring theory here and there in the lives. I think there was probably at least one live where we did more dedicated our time to kind of setting up sort of the premise for superstring theory. And then hopefully we will get a little bit more flavor from this book on the superstring theory. This is why I checked it out at the library. It's a physical copy, so they can't easily take it back from me, which is the case with some other books that I've also been mentioning on the channel. So hopefully this will be an interesting read and an interesting thing to talk about and reference. Thank you, Mysterious Maths. Read and write. Make a live stream, 9,000 million subscribers. Well, thank you so much. That would be excellent. So we will read at first about this book, and then we'll get into the book and actually read some of the topics as well. And depending on how that goes, we can also go back to the previous book that we were referencing, which is Brief History of Time by Stephen Hawking. And we were in the middle of something in that book. As it is, we were talking about the origin and fate of the universe. So I wanted to introduce this other book that's new to the channel real quick here. And then we will probably go back and finish up Stephen Hawking's book and then come back. That's sort of the plan. And then I'm ready to also take any questions, any comments as those come in. I will keep an eye out for that as well. Normal Guy says something. Hello, Normal Guy. Be careful. I don't know if the mods are here yet, and I don't know what you're saying exactly, but depending on Mysterious Matt says, please read my comment. If you're interested, I can share a few linguistic and scientific. I already read that comment, Mysterious Maths. What is the facts that you want to share? Go ahead. Go ahead. Go ahead, Mysterious. Delete Normal Guy. Something is hiding. Sorry, I don't see it. Mysterious Maths. Oh boy, I think it's raining here. I don't know where the mods are today. I don't know where everybody is, but I'm going to get started. Give me one more second. Actually, I'm rather thirsty. Nathan, are you still here? Nathan and whoever else. Okay. So, The Elegant Universe 25th Anniversary Edition. This is going to be the 25th Anniversary Edition. How's that water? It's very good, John Foster. Superstrings, hidden dimensions, and the quest for the ultimate theory. With a rare blend of scientific insight and writing as graceful as the theories it so deftly explains, The Elegant Universe remains the unrivaled account of the modern search for the deepest laws of nature. A standard that will be hard to beat, says George Johnson, New York Times Book Review. That's the sort of comment on this book. In this new 25th anniversary edition, renowned physicist and author Brian Greene, that is Green with an E at the end, the single best explainer of abstruse concepts in the world today, Washington Post says, updates his classic work with a new preface and epilogue summarizing the significant theoretical and experimental developments over the past quarter century, from established science, including relativity and quantum mechanics, to the cutting edge of thinking on black holes, string theory, and quantum gravity. The Elegant Universe makes some of the most sophisticated concepts ever contemplated, thoroughly accessible and entertaining, bringing us closer than ever to comprehending how the universe works. So that's the hi, hello Chickpea Break, hello Ver. That's the description of this new book that we're gonna touch upon here today. We're getting started with yet another book that we will be also looking at, along with Brief History of Time by Stephen Hawking, keeping things interesting. And another comment is, few humans share Green's mastery of the latest cosmological science and English prose. As rewarding as it gets, a thrilling ride through a lovely landscape. Brian Greene is the director of Columbia University's Center for Theoretical Physics and co-founder of the World Science Festival. Thank you so much. Thank you. My mod is here. Yay. Thank you so much, Chickpea. Can we get 20 likes? Can we get 10 likes? So Brian Greene, Columbia University, as you know, is in New York City, so not too far from Boston here. But I suppose that's where he works. And he is also the co-founder of the World Science Festival, acclaimed for groundbreaking discoveries in superstring theory. He is the author of 4 best-selling books and have collectively sold more than 2 million copies worldwide. He lives in New York City. I see you're home. Yes, I'm home. Thank you so much. Thank you for being here. So Brian Greene is big contributor to superstring theory and of course this book. So we will get his perspective because we've been sort of mentioning superstring theory here and there on these live streams quite a bit. And because I'm not myself an expert on superstring theory, I thought it would be good to read about it from the experts that have contributed to the theory and that have contributed such books like Brian Greene, and we can hopefully get a better understanding of what it all means. Because as you know, superstring theory, it is a candidate for the grand unification theory in physics, sort of a theory that attempts to unify general relativity and quantum mechanics. Initially, Einstein and others were trying to work on something that will bring together everything and can subsume the properties of quantum mechanics. They didn't really like quantum mechanics. And of course, general relativity, gravitation, electromagnetism, all of it would kind of fall under this larger theory. And this was not really achieved during Einstein's lifetime, but then string theory and superstring theory kind of started to take shape and become a thing in the years following, in the decades that followed actually his lifetime. So we will take a look at what Brian Greene has to say on the topic. This is quite a thick book actually. So we will take a look at parts of it at least and see what Brian Greene has to say on the topic, because that will be quite helpful, because it's hard to understand superstring theory. It's even harder, if not impossible, to kind of test the theory, which is why it can be a little bit sort of inconspicuous, because you don't really see a lot of news on superstring theory being tested. You can't really test it because it has all these extra dimensions that we generally don't experience as human beings. And so it makes it difficult to experiment with the theory. And so that's why it'll be interesting to read about it from somebody who has worked on it a lot, because generally this sort of thing is not available to all of the public. Super chat for Atom Book, someone, anyone. Thank you. Love it. Yes, I still have your Atom Book in mind. Somebody has requested it, Ver has requested it, and I do have that in mind as well. But this is just the book that I got from the library yesterday on the way back from the airport. The library was holding, see, look at this, Boston Public Library. So this book, I don't own it. It's from the library, and Boston Public Library did a hold on it for me until yesterday. So good thing that my plane landed on time and I was able to swing by the library, because otherwise they would have had to give it to somebody else. So basically this book, Quran, was revealed to Prophet Muhammad 1400 years ago in Mecca, Arabia. Hello, Mysterious Mats. Nathan says, yes. How's the water? Looks like it. Bikel Gaming. Hello. Thank you for being here. Quran has many scientific verses, more than 1,000, talking about astronomy, hydrology, embryology, geology, oceanology, and many more. Chickpea says, Chickpea, I see your home. Have those who disbelieve not considered that the heavens and the earth were a joint entity? I see Mysterious Mats is giving us some lectures from the Quran in the chat. That's all right. Thank you so much. This verse talks about Big Bang or the origin of the universe. Okay. Can we get 10 likes? Super chat for the Atom book. Thank you so much. Gabriella says, Jux the Umfraj. Hello, Gabriella. Not sure what you said, but thank you so much and welcome to the live. You should start scanning these books and keeping copies. I don't really have a scanner either. Actually, the library has one. So maybe I will. Anurag says, hi, where are you from? You didn't read the entire verse. Well, I'm a little bit busy. I can't read the entire verse always because I'm trying to go through the comments. And I think the people that are interested will read your verse and take pleasure. I actually have to share the live. So give me 1 second, guys. Hang on. Thank you so much for being here. I forgot my phone slash tablet, so I have to do it from the laptop against which you rest the phone. Oh my god, ad blocker. Go away! One of the most interesting facts of this is that Prophet Muhammad was not a scientific or educated professional. He was an unlettered person. Okay. The process of sharing this live from my laptop is less than ideal. Don't forget to mention me in the book you're writing. Thank you, Chickpea. Thank you so much, everybody. Can we get 20 likes? Can we? We are, let me type, we are live. Therefore, we believe that this Quran is from the creator of heaven and earth. Okay. Super Chat gets a huge shout out. Thank you. Like and subscribe. Okay, now that I've shared the live, I can come back to reality, which is this, gosh, how many Google Chrome browsers have I suddenly opened? Okay. Harper, hello. There, go away laptop brightness levels. Hi, Harper. Okay, so we will go back and read a little bit from the Brian Greene book. Okay, so I told you about the book. There is, okay, let's see. Let's take a look at this book. So we've got The Elegant Universe, Superstrings, Hidden Dimensions, and the Quest for the Ultimate Theory. This is by Brian Greene. The contents are part 1, the edge of knowledge tied up with string. Goodness gracious. Interesting title of that chapter there. Part 2, the dilemma of space-time and the quanta. Space-time and the eye of the beholder. Hi, Harper. Tornado sirens, yeah, makes sense. Space-time and the eye of the beholder, of warps and ripples, microscopic weirdness, the need for a new theory, general relativity versus quantum mechanics. So as we have discussed in the past as well, quite a few times on the channel, there is sort of this tug of war. There is sort of a bit of a debate between general theory of relativity and quantum mechanics. And so we will see how that all is presented by Brian Greene, because part of what we're doing here on the channel is not just looking at a topic once and that's it. We sometimes look at a topic multiple times with various perspectives, like various authors. We've covered Einstein's Cosmos by Michio Kaku. We're covering Stephen Hawking's A Brief History of Time, and now we're covering Brian Greene's The Elegant Universe and a few other books as well. We've especially covered astrophysics and astronomy from my Astronomy for Majors book that I have mentioned a lot on the channel, by Barbara Ryden and Bradley M. Peterson, as you guys know, if you're familiar with the channel. And so atom needs to be looked at again, yes. Also the book called Atom by Lawrence Krauss, as somebody's mentioning here. So we've tried to kind of get a flavor for all of these different topics from all these different perspectives, because these are quite important topics. So we don't want to just briefly touch upon them. We want to come back to them. So it'll be interesting to see what Brian Greene has to say for general relativity versus quantum mechanics. That's something that we have mentioned before on the channel, and how that kind of leads to the need for a new theory. In fact, he calls the chapter that. The Cosmic Symphony is his part 3. Nothing but music, the essentials of superstring theory. The super in superstrings, more dimensions than meet the eye, the smoking gun experimental signatures. Hi, Harper. Hi, Nathan. Harper, our tornado watch just ended. Audrey is chickpea. I'm chickpea break. Part 4 is string theory and the fabric of space-time. So out of that, we have quantum geometry, tearing the fabric of space, beyond strings in search of M theory. So remember, M theory is something that we've also kind of mentioned. I believe it has 11 dimensions versus superstring theory has 10 dimensions. So things like that, it will be good to deep dive into these topics from the perspective of a string theorist, because sometimes we kind of mention things and we come across them briefly, but we might not get to the meat of them unless we really hear from the expert. And remember how we talked a lot about and learned a lot about black holes from the Stephen Hawking book? Well, because he did contribute immensely to that particular topic, for example. So it's good to hear sort of from directly firsthand from the person who has contributed a lot to that particular topic. So that's good. Black holes, a string or M theory perspective. So again, we're going to get a perspective on black holes from a string theory, M theory perspective, and then reflections on cosmology. And then part 5 will be unification in the 21st century. Prospects is the chapter there. So unification in the 21st century might look a little different than what people might have been attempting in the 20th century. So I suppose that will get treatment here in the book by Brian Greene. So that's what we're dealing with in this book. Harper, sorry about the tornadoes. Sorry about the bad weather in the Midwest. Wish you were here on the East Coast. It got rough here when where I'm at for about 30 minutes. The rest was just a lot of rain. So you guys are getting a lot of wind and rain. The storm is like picking up, or is it just more like rain now? Okay, so we will skip the preface and go into, well, let's see. Does it look important? We will skip it for now. So we will skip the preface, or the preface to the preface. Maybe this is sort of the preface to the 25th anniversary edition. So we will skip the preface to the preface. Yes, it started at 8 and just coming to an end. That is too bad. Take care. Have a good evening, Harper. Try to. So this is the sort of the preface to the preface, and now we will talk about the actual preface, and then there's chapter 1 that will get started. Thank you, Nathan. It's very scary business. Wish you the best, Harper, says Chickpea Break. Good. Oh no, I feel bad. It's difficult. So, the preface of this book. During the last 30 years of his life, Albert Einstein sought relentlessly for a so-called unified field theory. So this is what I was talking about, where they were really looking for a theory that can subsume all of the known theories of that time, because some of those theories they didn't really like so much. For example, quantum mechanics. So they were kind of looking for, Einstein included, and Einstein was sort of a leader in this, trying to find a unified field theory. Get the key. So today I have eaten my dinner already. I've been really good. I did the gym first in the afternoon, and then I ate a big dinner with my mother because she's visiting. So I can't be bad and eat at various crazy times. So thank you, God, and thank you, universe, for today's dinner that I made. But but I've already eaten. So there's no need for the microwave and the ghee anymore. But you're right, I forgot to add the ghee to the chickpea today. I've been making sort of this chickpea salad every time I eat the chickpeas, and it's sort of a slightly different rendition each time. And sometimes I add the ghee, but indeed today I did not add the ghee. And today I made the chickpeas as well as today I made the chickpea salad for us, me and my mom, as well as I made dumplings with pork, actually. So that was my protein today. I don't really eat a lot of meat, but that's what I ate today. So I'm extremely full, and there's no more need for the microwave. I used the induction stove today and made dumplings. So oh, I'm glad you're here, Harper. Okay, so going back to this reading. During the last 30 years of his life, Albert Einstein sought relentlessly for a so-called unified field theory, a theory capable of describing nature's forces within a single, all-encompassing, coherent framework. Einstein was not motivated by the things we often associate with scientific undertakings, such as trying to explain this or that piece of experimental data. Instead, he was driven by a passionate belief that the deepest understanding of the universe would reveal its truest wonder, the simplicity and power of the principles on which it is based. Einstein wanted to illuminate the workings of the universe with a clarity never before achieved, allowing us all to stand in awe of its sheer beauty and elegance. Einstein never realized this dream, the dream of grand unification theory at least. The dream of many other things he did realize, such as, special theory of relativity, general theory of relativity. It's not like he was an unaccomplished kind of guy. But indeed, it is true that he wasn't really able to get to a totally grand unified theory in his lifetime. And even now, we don't really have that. The superstring theory, about which hopefully we will learn quite a bit from this book by Brian Greene, is sort of an attempt at getting to a more unified field theory. It's a candidate for the grand unification theory. But we will see about that as far as how it's explained here. Einstein never realized this dream, the dream of the grand unification theory, in his lifetime, that is, in large part because the deck was stacked against him. In his day, a number of essential features of matter and the forces of nature were either unknown or, at best, poorly understood. That is very true. A lot of the things like particle physics and sort of like the strong force, weak nuclear force, those things might have been quite a bit of a mystery still at his time. But during the past half century, physicists of each new generation, and by the way, let me tell you when this book was written in 1999. But then I think the 25th anniversary edition is as recent as maybe 2024. So that's that. In his day, a number of essential features of matter and the forces of nature were either unknown or at best poorly understood. So Einstein's time, that is. But during the past half century, physicists of each new generation, through fits and starts and diversions down blind alleys, have been building steadily on the discoveries of their predecessors to piece together an ever fuller understanding of how the universe works. And now, long after Einstein articulated his quest for a unified theory, but came up empty-handed, physicists believe they have finally found a framework for stitching these insights together into a seamless whole, a single theory that, in principle, is capable of describing all physical phenomena. The theory, superstring theory, is the subject of this book. I like the dress from the Riverwalk. Thank you. I saw someone earlier that had a similar channel. He had 170 viewers. So keep it up, B. You will get there. Thank you. Oh my gosh. So this is a jacket, by the way. This rather what's the word? Shiny. This rather shiny jacket is sort of a jacket that I'm wearing on top of a dress here for you guys to look professional yet party-y. And you remember my dress? What was I wearing? Oh yeah. Thank you. The Riverwalk was fun. I got very tired yesterday, so I did not go live. But here I am. Combat sports. What's the topic today? It's The Elegant Universe by Brian Greene. So the topic today is still cosmology. and we will touch upon superstring theory. I saw someone earlier. Oh, yeah, I read that. Oh, thank you, Nathan. Nathan Mullins, thank you for your encouragement. Combat Sports, hello. Handsome today, thank you. Welcome, thank you for being here. I'm here with my shiny jacket. Faith says you look nice. Thank you. Looks like the partying took all your energy. Today or the trip? JG2 goaded. Hello, welcome. Oh, I did yawn. That part? Okay. It's true. My bedtime is a bit earlier these days, and by bit I mean a lot. So you're right. It's a bit late for me right now. Why? Because I've been getting up earlier and doing a whole day, and I'm in the yawning. Yes, true. I've been doing a whole thing, and then I came live here today because I was doing plans and stuff with my mom, with my family, and some other work I had today. So I've had sort of a longer day. And by longer day, I mean I've had some longer days earlier in the day. JG2 goated. Hello. I meant the yawning. What? Wade. Hello, Wade. How are you? Can we get 20 likes? What's up, Oinery? That's me. I call myself Oinery sometimes because it's a difficult name that I have. We need a new book. We need some money. Chickpea break is what we need. Thank you so much for being here. Can we get 20 likes? Until I get money, this is all you get because this book is from the library. Library books is all we get. Boston Public Library has given us this book kindly. I wrote The Elegant Universe. Brian Greene speaks. I wrote The Elegant Universe in an attempt to make the remarkable insights emerging from the forefront of physics research accessible to a broad spectrum of readers, especially those with no training in mathematics or physics. So how nice and kind of Brian Greene indeed, because making these topics accessible is no joke and very much needed because the topics can be kind of difficult. I went to the library today. I went to the library yesterday. Through public lectures on superstring theory I have given over the past few years, I've witnessed a widespread yearning to understand what current research says about the fundamental laws of the universe, how these laws require a monumental restructuring of our conception of the cosmos, and what challenges lie ahead in the ongoing conquest for the ultimate theory. I hope that by explaining the major achievements of physics going back to Einstein and Heisenberg. So Einstein meaning the father of relativity. He gave us special theory of relativity and general theory of relativity. And Heisenberg, of course, gave us the uncertainty principle that many people did not like. The fact that quantum mechanics has the uncertainty principle, sort of this fundamentally uncertain nature, fundamentally probabilistic nature, giving us sort of uncertainty limits or errors on measurements, that is something that is not exactly well liked in the classical world. So, yeah. So anyway, I hope that by explaining the major achievements of physics going back to Einstein and Heisenberg and describing how their discoveries have grandly flowered through the breakthroughs of our age, this book will both enrich and satisfy this curiosity. Chickpea says, shiny, shiny, shiny. Hello, Chickpea. Hello. I also hope that The Elegant Universe will be of interest to readers who do have some scientific background. for science students and teachers. Yay! I hope this book will crystallize some of the foundational material of modern physics, such as special relativity, general relativity, and quantum mechanics, while conveying the contagious excitement of researchers closing in on the long sought unified theory. For the avid reader of popular science, I've tried to explain many of the exhilarating advances in our understanding of the cosmos that have come to light during the last decade. And for my colleagues in other scientific disciplines, I hope this book will give an honest and balanced sense of why string theorists are so enthusiastic about the progress being made in the search for the ultimate theory of nature. Hello, Bat. Shite. Carese. How are you? Superstring theory casts a wide net. I don't know if Harper left. That could be the case. I can't really see. Hello to everybody. Hello, Wade, Chickpea, Batshite, GJ, whatever. All the people. Thank you so much for being here. Welcome. Thank you and welcome. Thank you. Superstring theory casts a wide net. It is a broad and deep subject that draws on many of the central discoveries in physics, since the theory unifies the laws of the large and of the small. So large as in relativity, small as in quantum mechanics. At least I hope so anyway. Because if you can't, oh, sorry. Hello, JG2 Goated. Thank you for correcting right there. JG2, hello. Thank you so much. Anyway, hopefully Superstring Theory by Brian Greene here will shed some light on the unification of the large and the small as in relativity as well as quantum mechanics, because without unifying those two, a theory that claims to be sort of a candidate for unification is a little odd. It may very well be impossible to test superstring theory, but I would like to see what it is, trying to say, trying to explain, trying to do. So that's hopefully what we get out of this. Thank you so much for being here. Can we get 20 likes? Can we share the live or something? So, since the theory unifies the laws of the large and of the small, laws that govern physics out to the farthest reaches of the cosmos and down to the smallest speck of matter, there are many avenues by which one can approach the subject. The book is closing. I have chosen to focus on our evolving understanding of space and time. I find this to be an especially gripping developmental path, one that cuts a rich and fascinating swath through the essential new insights. Einstein showed the world that space and time behave in astoundingly unfamiliar ways. Now, cutting-edge research has integrated his discoveries into a quantum universe with numerous hidden dimensions coiled into the fabric of the cosmos, dimensions whose lavishly entwined geometry may well hold the key to some of the most profound questions ever posed. Although some of these concepts are subtle, we will see that they can be grasped through down-to-earth analogies. Thank you, JG. No, I can say your full name. Thank you, Chickpea. Speaking of string theory, have we ever actually proven gravity or gravitons more specifically? No. We have measured gravitational waves from neutron-star collisions So we have direct measurement of gravitational waves, which is a prediction of general theory of relativity. But as far as if you're asking if we have unified gravity with the rest of particle physics, then I believe the answer is no. Unless I'm mistaken, the fundamental forces of nature, as you know, are gravitation, electromagnetism, strong nuclear force, and weak nuclear force. Those are the four forces that we know of. Quirky questions. Well, quarks are what are involved in the strong nuclear force, actually, as well as the electromagnetic force. So certain particles interact with more than one. Anything with mass, of course, interacts with gravitation. We know that because masses and gravitation, those things, we get it. But as far as sort of a unification or coming together of the forces are concerned, we have much better luck trying to unify the weak nuclear force and the strong nuclear force with electromagnetism, and kind of having a sort of trifecta, if you will, of those three things. And some people call that a unification theory or a unified theory, but it's not truly a unified theory if you don't also account for gravitation. So gravitation is still explained with general theory of relativity. Pretty much, if you ask today, what do we know about gravitation? The most updated theory for gravitation is the general theory of relativity. It's a correction to Newtonian gravity. It's a correction to Newtonian mechanics and laws of gravitation, which, by the way, work for the most part. NASA is still using them, but if more corrections are needed, then general theory of relativity does a good job. Okay. And then there's, of course, quantum mechanics and what came out of it, which is particle physics, which then gives us particle nature of light and matter and everything. Like basically matter breaks down into subatomic particles, things like that. So basically we've got gravity irks your nerves. I would say what irks me is that we still don't have a unification between gravity and quantum mechanics that even these people have been trying for a long time, a testable theory anyways. So like I said, it's a good thing that we will get an explanation of superstring theory from Brian Greene here in this book, hopefully. But in general, not being able to sort of unify these four fundamental forces, meaning gravitation with the rest of the three, is irksome for sure. It's not that gravitation is the problem there. The problem is putting it all together is a challenge. So, but yeah, I don't know, but as far as I know, we haven't really found the graviton. But I will say that being able to measure the gravitational waves from cataclysmic events very far, far away, as predicted by general theory of relativity, is a big win for Einstein. It's a big win for astronomy, multi-messenger astronomy, and those types of things. And it's a big win for experiments. Basically, we've come a long way in being able to measure things and in being able to observe things. So that's where we've made a lot of progress. I don't know that we have necessarily understood more insightful, like the things like further understanding of gravitation, what it means even more deeply, how it kind of plays together in particle physics. Can it really be unified or not in that sense? And then also, of course, we don't know dark energy and dark matter. And when these ideas are understood, they provide a startling and revolutionary perspective on the universe. So Brian Greene is saying, although some of these concepts are subtle, we will see that they can be grasped through down to earth analogies. And when these ideas are understood, they provide a startling and revolutionary perspective on the universe. Throughout this book, I've tried to stay close to the science while giving the reader an intuitive understanding, often through analogy and metaphor, of how scientists have reached the current conception of the cosmos. I guess he has to provide metaphors and analogies because the topic that we will discuss here, superstring theory, I mean, I don't know because I haven't read the book fully. But those topics are highly mathematical and geometrical. Superstring theory, as far as I understand it, is a very geometry explanation of everything. So it's going to be difficult to just kind of say it in words. So I think he will probably make use of a lot of analogies and metaphors. We will see. We'll see what we feel about that when we get to those parts. Although I avoid technical language and equations, says Brian Greene, because of the radically new concepts involved, the reader may need to pause now and then to mull over a section here or ponder an explanation there in order to follow the progression of ideas fully. A few sections of part 4, focusing on the most recent developments, are a bit more abstract than the rest. So let's see, part 4 is string theory and the fabric of space-time, so makes sense, quantum geometry. I was going to say quantum gravity, it's quantum geometry, tearing the fabric of space, M theory, black holes, okay, whatever. I've taken care to forewarn the reader about these sections and to structure the text so that they can be skimmed or skipped with minimal impact on the book's logical flow. I've included a glossary of scientific terms for an easy and accessible reminder of ideas introduced in the main text. Oh, good. Yes, there is a glossary. Although the more casual reader may wish to skip the endnotes completely, the more diligent reader will find in the notes amplifications of points made in the text, clarifications of ideas that have been simplified in the text, as well as a few technical excursions for those with mathematical training. Ooh. That could be nice. I owe thanks to many people for their help during the writing for this book. David Steinhardt read the manuscript with great care and generously provided sharp editorial insights and invaluable encouragement. Few more Davids have been thanked here. Got it. Some Michael, some Ken, whatever. Others who read all or part of the manuscript and offered advice. Special thanks to Raphael Gunner for, among many things, his insightful criticisms at an early stage of writing. Great. So he thanks some people. That's good. Okay, great. So that's sort of the preface of this book. There was a preface to the preface because this is an anniversary edition, but we kind of skipped that. We will launch into part 1 right here, right now, which is called the Edge of Knowledge, and see what he's going to say. Get a feel for it, and we can always keep on discussing whatever we're reading, by the way. If you have any comments, questions, chats, thoughts, ideas that you want to say, put them in the chat. Happy to read it. So this chapter, which is part of this first part, which is called The Edge of Knowledge, is called Tied Up with String. Very interesting naming. Of course, he means string theory. He is a string theorist, so he can put the word string anywhere he wants. But yeah. Recess? Yeah, I kind of need to grab some water, actually. Basically, yeah. The Edge of Knowledge, coming soon in a theater near you, summer 2050. All right, let me get some more water. This is This is too funny. Insert string theory. No, I think what I mean is the word string. The word string can be anywhere. It's a play on words, I believe. This first name of the chapter. All right, give me 1 second. It's gotten cold. All right, I'm here. Okay. About to fall, but here I am. I'm definitely a little tired today, I must say. Okay. Whoops, I spilled. Tomorrow? Okay, interesting message there. Lots of emojis. Tomorrow I'm gonna try to go light in the afternoon so that I'm not so tired and it's closer to the beginning of my day. The beginning. Okay. Hopefully that works for you guys and you can always see my live later on if you are not free in the afternoon. Okay. Tied up with string. Calling it a cover-up would be far too dramatic, but for more than half a century, 50 years, even in the midst of some of the greatest scientific achievements in history, physicists have been quietly aware of a dark cloud looming on a distant horizon. The problem is this: there are two foundational pillars upon which modern physics rests. Quiz question: what are the two foundational pillars on which modern physics rests? Who wants to say in the chat, what are these two foundational pillars? Hint, one of them starts with a G, another starts with a Q. Unless I'm getting it wrong myself. We will read in the next sentence. I stop reading to give this quiz both to me and you. Wake up. Gravity. Steven. Hi, Steven. Steven. How are you? Thank you for liking the live. So I think the foundational pillars on which modern physics lies. Gravity, what are the two foundational pillars on which modern physics lies? That's the question, quiz question for my chat. So now gravity is pretty old, but I think you're close. I gave the hint, G and then Q. So I think the two foundational pillars that Brian Greene is talking about. So Stephen, we're talking about Brian Greene's book, The Elegant Universe, by the way. You're late. Stephen, after the live, you might want to rewind. Okay, quantum mechanics, yes. I believe that quantum mechanics is one of the foundational pillars upon which modern physics rests. And the other is, yes, the other is general theory of relativity. That's the G I meant. Sorry if that wasn't clear. I meant G for general theory of relativity and Q for quantum mechanics are indeed foundational pillars of modern physics, but they kinda don't always agree. General theory of relativity. They kind of don't always agree. So there are two foundational pillars upon which modern physics rests. One is Albert Einstein's general relativity. Yay, I got it. It was a quiz for me too. Which provides a theoretical framework for understanding the universe on the largest of scales. Stars, galaxies, clusters of galaxies, and beyond, to the immense expanse of the universe itself. Steven, did you get it? Hi, Germany Pro. Doro, hello. Hello, JG. Hello, Doro. Hello, Germany Pro. Hello, El Challen. So, Einstein's general relativity is one of the foundational pillars of modern physics and explains the universe at the scales of stars, galaxies, clusters of galaxies, and beyond. The other is quantum mechanics. Yes, we got it. I know that multiple people in the chat knew quantum mechanics was one of the foundational pillars of modern physics. That's the key word, modern physics. In general, as you know, gravity as a topic is pretty old. Newtonian gravity is, of course, very old. It's been updated and corrected by Einstein in his general theory of relativity, which is the updated theory for gravitation. So those are the two foundational pillars of modern physics: general theory of relativity, quantum mechanics. And do these theories always agree? No. That's the drama. And we will see how Brian Greene addresses that drama right here, right now. Ladies and gents, listen up. Hello, Doro. Hello, Stephen. The other is quantum mechanics, which provides a theoretical framework for understanding the universe on the smallest of scales, molecules, atoms, and all the way down to subatomic particles like electrons and quarks. Through years of research, physicists have experimentally confirmed to almost unimaginable accuracy virtually all predictions made by each of these theories. But these same theoretical tools inexorably lead to another disturbing conclusion. As they are currently formulated, general relativity and quantum mechanics cannot both be right. Whoops! The two theories underlying the tremendous progress of physics during the last 100 years, progress that has explained the expansion of the heavens and the fundamental structure of matter, are mutually incompatible. If you have not heard previously about this ferocious antagonism, you may be wondering why. The answer is not hard to come by. In all but the most extreme situations, physicists study things that are either small and light, like atoms and their constituents. So atoms, subatomic particles, etc. Those are sort of the quantum mechanics, quanta meaning small type of things, or things that are huge and heavy, like stars and galaxies, but not both. Generally, people don't study both. Unless you're Stephen Hawking, he kind of studied both, to be honest. Gotta give the credit where it belongs, right? He kind of was at least a good student. I guess I meant to say Stephen and then student. So he was sort of a good student of both. Dora says, no ladies here. Everyone on the internet is a man. Is that true? What? Is that true? What's up, El Challen? I don't study. I got lucky. Don't let out the iceberg. Gravity would be considered a weak force, correct? Well, it's not the weak nuclear force, if that's what you're asking about. But that's an interesting question. Are you asking if gravitation and the weak nuclear force have some kind of relationship? Because if they do, I know not of it. The weak nuclear force, the electromagnetic force, and the strong nuclear force can sort of be unified depending on the energy regime of it. But these three things have not been unified with gravitation, as far as I know. So gravitation being a force that is always attractive, it's much weaker than the electromagnetic force. That's true, but it's not the weak nuclear force. That's quite a different thing. And the weak nuclear force, by the way, the weak nuclear force and the bosons that carry the weak nuclear force, the W and Z bosons, those being discovered and all that stuff was a big deal. So again, those are sort of progresses in quantum mechanics and not giving us explanations in terms of GR or gravitation, really. Okay. So so generally, physicists are people who either study small things like quantum mechanics, or they study big things, heavy things like stars and galaxies and gravitation. Gravitation is mainly something that comes into play when there is a lot of mass, for example. And so it is very important when it comes to the stars and the galaxies. And we even found that there's this other extra thing called dark matter only because we can't really see it, but we see it interacting with gravitation. So we see the expansion of the universe and how there's sort of this anti-gravity going on in the universe, which helps it to expand against gravitation, and things get farther apart with time. So in those types of scales, gravitation is important, but in the quantum mechanics scales, we don't really have an explanation of gravitation. Gravity is the only thing keeping me down. So are you catching a flight, Doro? Is that why you're not going to be kept down? Or are you going to be on a balloon? I was asking because if gravitons are theoretical quantum particles and it's so much weaker in comparison to the other forces, how could we ever hope to measure them? I don't know. I don't know. Are you asking energy regime wise? Is it very much weaker or something? Thank you, Doro. So I have to think about that. I don't know. Yeah, I have to think about that. As far as I know, there's no. So you know how the electromagnetic force, the weak nuclear force, and the strong nuclear force kind of come into play in different energy regimes? And so there's sort of a way to unify them. But as far as I know, there's not a way to unify these three that I just mentioned with gravitation. And that's really the challenge, okay? Okay, so most people don't study both the large and the small types of physics. This means that they need use only quantum mechanics or only general relativity and can, with a furtive glance, shrug off the barking admonition of the other. For 50 years, this approach has not been quite as blissful as ignorance, but it has been pretty close. So for 50 years, because I do believe that it was maybe, if I'm not mistaken, it was 50 years after Einstein's death that superstring theory really became a thing. And so for 50 years, the general relativity people were probably saying bad things about the quantum mechanics people. And the quantum mechanics people were probably saying bad things about the general relativity people. But because you don't have to mix the two too much, if you're doing large scale stuff, if you're doing galaxy and stars, you would do general theory of relativity, you would do astrophysics, etc. And you don't have to think too much about quantum mechanics. And if you're doing quantum mechanics, then you study atoms, inside atoms, quarks, you try to discover a new particle or a boson, Higgs boson, for example. And you don't really care about the large scale stuff like general theory of relativity. So these two types of camps did not really have to unify and use each other's physics too much. And so they're able to get along by basically not getting along and not using each other's work. Steven, my last name is the same as a dumb singer. I like Britney Spears. What's? They all sound so sassy. Who, physicists? They're very sassy people. Physicists will fight each other all day. It's part of the culture to tear each other down. Like the GR folks tearing down the quantum folks is very normal. And the quantum folks not attending the conferences of the GR folks, again, very normal. So the people who worked on string theory are, kind of brave if they're trying to intertwine the two and unify the two. And someone like Stephen Hawking, Hawking radiation, the quantum effects around a black hole leading to black holes having a temperature and emitting particles. So in other words, black holes are a general relativity prediction. Then including some kind of quantum mechanics to explain something about black holes. That's again very brave. I mean, that's why Stephen Hawking is famous. So yeah. She's a distant cousin according to my daddy. Who, Britney Spears? Can you like, share, subscribe, and ask her to like the live? That would be most helpful, Steven Spears. And maybe she could share the live too. Physicists are liberals. Of course, they're sassy. They're not always liberals. JG2, thank you for the emojis. Quantum folks are lame. Both fields are so cool. That's true. Both fields are very cool. Definitely ask Britney Spears to like the live. I mean, why not? I think she would like it. I like relativity a little more, kinda. Yeah, I don't even know her, never met her. You know, Steven, maybe you should give her songs a chance. Then you'll meet her. Poor girl. You know, you don't gotta be so... Don't be so harsh on your cousin, Steven. Give her a chance, okay? Hit me, baby, one more time. La, 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 la. Give her a chance. You know? Give her a chance. I think I like relativity a little more. To be honest, relativity is pretty cool. It really is. I think Toxic. I forget the name. I don't know that song. I mean, not off the top of my head. I actually don't know Britney Spears that well. I mean, her songs. But Steven, you should give her a chance. I think they still make her perform in Vegas. They still make her perform? What do you mean? Who's making her who's making this poor girl perform? She should not perform if she doesn't want to. You know, you can accept more than one famous relative. Don't be so harsh on Britney. Okay. So, for 50 years, this approach has not been quite as blissful as ignorance, as in the people who don't work with each other, ignoring the small physics people, ignoring the large physics people, and vice versa. But it has been pretty close. So it's sort of a way to ignore the reality, which is that the two things don't really agree. And what's the flaw of that? My name is Baikal Sreshtha. Hello, Baikal. How are you? Felipe, hello. Felipe, can you please like the live? Can we get 20 likes? But the universe can be extreme. In the central depths of a black hole, an enormous mass is crushed to a minuscule size. At the moment of the Big Bang, the whole of the universe erupted from a microscopic nugget whose size makes a grain of sand look colossal. There are realms that are tiny and yet incredibly massive, therefore requiring that both quantum mechanics and general relativity simultaneously be brought to bear. For reasons that will become increasingly clear as we proceed, the equations of general relativity and quantum mechanics, when combined, begin to shake, rattle, and gush with steam like a red-lined automobile. Put less figuratively, well posed physical questions elicit nonsensical answers from the unhappy amalgam of these two theories. Even if you're willing to keep the deep interior of a black hole and the beginning of the universe shrouded in mystery, you can't help feeling that the hostility between quantum mechanics and general relativity cries out for a deeper level of understanding. Can it really be that the universe at its most fundamental level is divided, requiring one set of laws when things are large and a different incompatible set when things are small? Superstring theory, a young upstart compared with the venerable edifices of quantum mechanics and general relativity, answers with a resounding no. Intense research over the past decade by physicists and mathematicians around the world has revealed that this new approach to describing matter at its most fundamental level resolves the tension between general relativity and quantum mechanics. In fact, superstring theory shows more. Within this new framework, general relativity and quantum mechanics require one another. Wow! Requiring one another. How romantic between these two. Require one another for the theory to make sense. According to superstring theory, the marriage of the laws of the large and the small is not only happy but inevitable. That's part of the good news. But superstring theory, string theory for short, takes this union one giant step further. For 3 decades, Einstein sought a unified theory of physics, one that would interweave all of nature's forces and material constituents within a single theoretical tapestry. He failed. Now, at the dawn of the new millennium, proponents of string theory claim that the threads of this elusive unified tapestry finally have been revealed. String theory has the potential to show that all of the wondrous happenings in the universe, from the frantic dance of subatomic quarks to the stately waltz of orbiting binary stars, from the primordial fireball of the Big Bang to the majestic swirl of heavenly galaxies, are reflections of one grand physical principle, one master equation. I do like this language of Brian Greene, I have to say. I like these words. Because these features of string theory require that we drastically change our understanding of space, time, and matter, they will take some time to get used to sink in at a comfortable level, but as shall become clear, when seen in its proper context, string theory emerges as a dramatic yet natural outgrowth of the revolutionary discoveries of physics during the past 100 years. Wow. In fact, we shall see that the conflict between general relativity and quantum mechanics, is actually not the first, but the third in a sequence of pivotal conflicts encountered during the past century, each of whose resolution has resulted in a stunning revision of our understanding of the universe. Yay! And then we will talk about the 3 conflicts. In fact, we will start with the 3 conflicts next time. The 3 conflicts won't take too long. Oh, I see. We have actually seen these things before. By the way, a lot of this is going to be review, which is good. It's good to see a thing more than once for it to really sink in. So this is going to be great. Muon. Muon neutrino. Charm quark, strange quark. Yay! And he has tables. How nice. Goddess? What does that mean? I'm 65 million years old. I killed the dinosaurs. The dilemma of space, time, and the quanta. Progress in science proceeds in fits and starts. What is your surname? Are you asking me, my darling? Are you asking me? Steven. I like Lady Gaga. Bad romance. It's Michael asking me my surname. My darling, at some point, I guess that will become a thing. For now, let's just chill. Okay, Doro? I wasn't about to say my surname. Gosh. Can we get 20 likes? Jesus. All right. Tomorrow we're going to talk about the 3 conflicts. I'm going to turn on the dishwasher now and wind down. So I'm very tired. Can we get 20 likes? If you're seeing this as a video upload later on, we're going to do... continue this topic tomorrow, and I think I'm gonna go live in the afternoon after my gym because I'm getting too tired in the nighttime, and I shifted my schedule up a bit. I don't want to know your surname, but what I want to know is, did you have a good trip? Yes, my family is in North Carolina. It was amazing. As always, so much sunlight. I mean, there's sun here too in Boston. Why were you in North Carolina? Yeah, my family's there. And yeah, it was lovely. How are you guys? Did you see my North Carolina lives? It was fun. My phone just fell on my face, so it's definitely time to go to sleep. Aw, so I think, yeah, we will do some of these lives at night as well. But I'm going to do some in the afternoon. More like a daytime. More like a daytime one, so that I'm more awake and maybe in the midst of nature or outside or something. Just chilling like a villain. Hi, El Challen. I saw one where you were nervous of other people. Yes, so I had a lot of privacy in that patio, but then there was somebody who came out of the neighbor's sort of fence up into the tree, and I think they were cutting branches of that tree or something, and I felt a bit shy. Yes, indeed. Make a live stream, 100 likes, please. Will you make one for her? Hopefully I can catch the afternoon lives. Well, even if you can't be there during the live, you can still see it as it gets posted. So JG2 goated, I do hope that you catch the lives either during the live or afterwards when it's posted. Tomorrow's live stream, yeah. Tomorrow we're gonna do an afternoon, like afternoon as in later afternoon, evening live. Well, you should ask the questions in any of the comments of any video, really. JG2, am I saying this name correctly? JG2 goated. I have mad questions to ask, but my brain is running on fumes right now. JG, tonight is live stream. JG, you can ask your questions throughout the day. Say if you're at work and bored or something, you can ask the question during the day on any of the comments as a comment on any video. And I'll probably see it and I'll try to address it during the live. People leave me comments all the time on random other videos and I see it. Oh my god. Okay, I'm quite tired, guys. I'm so sorry. Ask my favorite AI app. Grok. I have to go. I'm gonna turn on the dishwasher. I mean, I wore my shiny jacket. I wore my shiny jacket for you guys so I could do this like live and everything, but I'm so tired. I'm so tired. Grok sucks. I don't know what GROK is. What is that? Tell me, guys. What is Grok? Tomorrow's live stream, please. Big fan. You know, Bikel Gaming, we will definitely go live tomorrow. Thank you for being here. Thank you. Please do be there tomorrow. Please do be there tomorrow. Is that a right sentence? Yes. Please do be there tomorrow. I'm very tired. Bikel Gaming, see you tomorrow afternoon. My time afternoon. I'm on the Eastern Standard Time Zone. See you tomorrow. Afternoon, early evening. Later in the afternoon, early evening time. Tomorrow. See you. After the gym, I may even do a car live. Tomorrow, maybe I'll do a car live. Because my mom is visiting. When I'm home, I get distracted with my chatting with her. And I do too much laundry. She makes me do too much laundry. Oh shoot! There's laundry in the basement. Did I change it to the dryer? I did. Okay. I did change it to the dryer. Oh my god. I changed the laundry to the dryer. I'm gonna go down tomorrow and get my laundry. I'll fluff it and I'll get it tomorrow. Dora, shut up. No, we did land on the moon. We have rocks from the moon. I'm gonna switch my laundry tomorrow. I have a little bit in the washer, but mainly I have some in the dryer. At least I switched to the dryer. I did that. I'm gonna do it the next step tomorrow. I've had such a long day. Oh, I upped my weight at the gym. Like this. Sunlight. Oh, Michael is from Nepal. Welcome to Nepal. Go to bed. Always remember. Oh! Dora. I'm looking on Nepal. Oh, poor baby. Let him work in Nepal. Thank you, Doro. Thank you for your support. Nepal is a beautiful country. See you tomorrow, Nepal. Nepal has the highest mountain in the world. See you. Oh, actually, you guys can chat for a bit. You guys can say goodnight and chat for a bit. I gotta start the dishwasher, so I'll still be here. Oh, and I need to take an antihistamine. Oh. Oh, God. Oh, my God. I took a Zyrtec. Started the dishwasher. Oh my god! Oh, my children are here. Let me show you. Hi, Steven. Hi, Felipe. What are you talking about? The kids are here. Oh my god. Alright. Can we get 20 likes? Can we get 20 likes? Can we? Baikal, can you please tell me again tomorrow about Nepal? What are you asking about my daytime? What are you asking about my daytime lives? Alright, yes, these are the kids I've birthed. Thank you so much. Thank you, chat. Bye bye. Bye bye.